Alright, so now that you're completely terrified of pre-multiplied and unpremultiplied alphas, and you should be, you should fear and respect it, let me just show you, it's really not so bad. It looked really complicated there, but that's just because you didn't get a really good demonstration of how it works. So let's just do that. Let's go ahead and we'll render this out. Okay, so here comes the teapot. Okay, here's a render of our teapot. Now in Max, it already shows you this image pre-multiplied. Here's our alpha channel. Now we have the option when we go to save it out. I'll save it in here. Let's call this T premult.tga. We'll leave that checked and we'll save it out again, and we'll call this straight. Okay, and this time we're going to uncheck premultiplied alpha. Okay, so we've just saved those out. We'll go back into Fusion and let's bring these two in. Alright, so the pre-multiplied one, this is how we're used to seeing our renders, and here's the straight one. It's got those jagged edges just like we saw last time, but yet the alpha channel of both of these is identical. So the pre-multiplying happens to the RGB channels. It has nothing to do with the alpha channel directly. It's just that in a pre-multiplied render, the alpha channel is used to darken the edges of the RGB channels. Now I'll show you that if we use that Boolean again and we just say divide by the alpha, and in this one we're going to do nothing aside from the white background, which is a result of dividing by 0. It's the same. I mean, you get the exact same results for the most part. You do get a little bit of weirdness. Let's see, right about here you'll see it. Or I'm sorry, right here. See that little dark pixel? The reason that's happening is because of bit depth. And I guess we should start talking about bit depth next. Basically what's happening is this is an 8-bit image, and what that means is that with 8 bits we have 256 different possible color combinations for each R, G, and B channel. But let's say you have a pixel that's I don't know, what's a good number, like 75. Okay, let's say the red channel, that pixel has a value of 75. Well, you can't divide 75 by 2 and get an integer. You get, a decimal point. And when you divide by values like that, you don't get an accurate number here. So it just kind of rounds it off, and it's called a rounding error, and that's why you get these occasional weird pixels, these dark ones, or sometimes they're light, and that's it. But in this case it's not going to cause us a problem, because when we go and multiply it back again, you're getting almost the exact same result again, but it's in the area that's almost completely transparent anyways, so I have never seen it become a problem. But just so you know, that's why these little dots are showing up. So let's go ahead, hopefully this makes sense now. Let's start talking about bit depth next. And actually, before we move on, I just want to point out that it is possible in Fusion to divide or unpremultiply and get a black background, but it requires using a custom node, a custom filter node, and then putting in an expression for each RGB channel, like writing out a mathematical equation that says, you know, divide the pixel by the alpha, but if you divide by 0, return black. So it is possible, but in almost every case, you're going to later on pre-multiply that alpha again, and this white area is going to go away. I've never been in a situation where this white background caused me a problem at the end of the flow, so I wouldn't worry about it. I know it looks kind of ugly and can be distracting, but it's easier than dealing with writing out an expression, so don't worry about it. It'll be fine. Alright, we're going to look at another situation that goes hand in hand with pre-multiplication, and that is rendering on different colored backgrounds and what that does with the pre-multiplied edge. Most of the time you should be rendering on black or white background colors. Here I have just a 100% self-illuminated teapot with some motion blur to help show these edges a little bit better. It's just a middle gray, 50% gray. And what I've done here is, here's my background, which is also 50% gray. And when I merge these together, we don't see any edge. It's perfect. And if we look at the alpha channel, you can see the teapot is there. It's just sitting right on top. Now, what if you got yourself into this situation and you had rendered your teapot on a color background, or maybe somebody gave you a pass that was rendered on a different color background? Well, this can cause all kinds of problems when you're compositing, because this edge was pre-multiplied with this color. And so if you were to put this directly over, let me just pull these off for a second. If we put this directly over, well, first of all, this area, because there was no alpha there, is becoming white because it gets blended additively where there's no alpha. So we can make it subtractive so that it doesn't do that. But here's that edge I was talking about. And I mean, this you can't work with that. You got to fix that. So what I'm going to do is I'm going to put this back in place, and we're going to look at what this is doing. So let me connect these back up. Okay. The way in which you remove this color and still keep everything working perfectly is that you first need to isolate what you're working with. So what we want to do is pump this into a channel boolean, and that channel boolean we're going to set to negative, and we're going to put the alpha channel into the RGB. So we've got white where it used to be black, black where it used to be white, and then the next step is to figure out what that color is. Now to do that, I just used a background and this little color picker, and wherever we select, it's going to select that color for us. So what you do is you take that and you multiply it over the result of your negative alpha. So I'm just multiplying the RGB colors. So we got black and the color, and now what we can do is we can subtract it. So with this channel boolean, what it's doing is it's subtracting the RGB of this, which makes sense. See, we've got black here, so this is doing nothing, and then the color. So we subtract it. Now we've got the teapot on a black background, and when we merge it all together, it's perfect. So that is how you can remove a solid color from a background if you've rendered it pre-multiplied against it. Now we can take this another step further. Here we don't have a consistent color background, so it gets a little bit trickier here. In fact, in order for this to work, you need to be able to isolate that background. So as long as you can produce that same exact background without the teapot, then you're in luck. You can make this work. So I rendered that grayscale by, or this not grayscale, this gradient by itself. So we've got the T-plot, and we do the same exact steps. We're going to do the negative, copy it to the alpha to the RGB, and we take our background colors, we multiply it over this. So again, black, this should do nothing. These colors will be subtracted. So that's what we do. Subtract it just like before. Now it's on a black background, and when it's merged over, it's almost perfect. If I zoom in, you can see it here. It's not completely perfect. The reason it's not perfect is just because of, well, the bit depth that we're working with. You only have so many numbers available to do all this math with, so you know, you kind of have to work with this, unfortunately. Or you can get better results than this by going up to a floating point. These were 16-bit images, and even though there's a lot of numbers available there, it still isn't quite enough to get rid of this. So let's go up a notch, and I did something very similar but in floating point. So this is all floating point, same thing with the background, same exact setup. Negative, multiply the colors, subtract, and then merge over. And then now it's almost completely gone. You can just barely make out that there's a little bit of edge there. But it's pretty clear that having more bit depth helps you get rid of the problem. And I think this would probably be enough that you wouldn't really notice it. So that's what you do. If you get passes or you've rendered passes on a color, that's how you remove it. You do the negative, multiply the color over, subtract from the original render, and you're good to go. Now, even though you can fix the problem, I still highly recommend that you just render on black or white and completely avoid this whole situation. It's nice that there's a way to get around it, but don't do it unless you have to.